Hi students, this is Dr. Arbalaji, Physics faculty. Here I would like to give a lecture on optical fiber. In this video, I explain about the principle of optical fiber. Optical fiber is a hair-thin dielectric waveguide through which we send the light energy from one end to other end based on total internal reflection phenomena. Now, what is a total internal reflection phenomena and at what situations this concept which is exist? The phenomena of total internal reflection takes place when the ray travel from denser media to rarer media. This is the first condition. Second one is the incident angle is more than critical angle. The ray is reflected in the same media. So whenever these two conditions are satisfied, then the ray reflect in the same media. So total internal reflection phenomena takes place when it is satisfied the following two conditions. Condition 1, light should travel from denser media to rarer media, that is n1 greater than n2. And second condition is the angle of incident on core and cladding interface should be greater than the critical angle. Now let us consider this diagram. Say this is denser media and this is rarer media. Now let us consider a ray which is traveling from denser media to rarer media. That is, the first condition of total internal reflection phenomena is satisfied. This is the normal. When a ray traveling from denser media to rarer media, it bends away from the normal. The angle between the incident ray and normal is called incident angle. The angle between the normal and refracted ray is called refracted angle. This is incident angle and it is refracted angle. So to satisfy the Snell's law condition, suppose a ray travels from denser media to rarer media, it bends away from the normal. Whereas a ray travels from rarer media to denser media, it bends towards the normal. So this situation which is occurs to satisfy the Snell's law. Snell's law is nothing but mu is equal to sin I by sin R. Suppose this incident angle you are making to increase, then this refracted angle is also increases. At a particular situation, at a particular incident angle, this is the refracted ray. So at this particular incident angle, the refracted ray grazes or touches the interface of denser media and rarer media. At the situation, this is called incident angle and this is the refracted angle. So at what incident angle the refracted angle becomes 90 degrees, that incident angle is called critical angle. Now for this system, the Snell's law is n1 sin I is equal to n2 sin R. This is called Snell's law. If I is equal to theta c, it means at critical angle. What is the value of R? 90 degrees. Then how this expression can be written? Sin theta c is equal to n2, sin 90 is equal to 1. Now from this, sin theta c is equal to n2 by n1. Now sin theta c can be written as sin inverse n2 by n1. So this is the critical angle at the interface of denser and rarer media. So sin inverse of the refractive index of the rarer media by the refractive index of the denser media. Suppose the incident angle is more than critical angle. The incident angle is more than critical angle. Then the ray reflect in the same media. The ray reflect in the same media. This phenomena is known as total internal reflection phenomena. Based on this total internal reflection phenomena, the light signal which is travel from one end to other end based on the multiple total internal reflection phenomena. In case of optical fiber, This is the core. Its refractive index is N1. Next layer is, this is represents cladding. Its refractive index is N2. And the refractive index of the core is greater than the refractive index of the cladding. This is axis. Now, say the surrounding media is air. Suppose a light is launching into the optical fiber. It means you are entering from air to glass. It means you are entering from rarer media to denser media. Then the ray bends towards the normal and incident at this position. Now here the ray which is enter from core region to cladding region. It is enters the interface of core and cladding. Core refractive index is more than the refractive index of the cladding. It means the first condition of total internal reflection phenomena is satisfied. Suppose this incident angle is more than critical angle, then what happens? The ray reflect in the same media. Suppose here also the incident angle is more than critical angle, the rays reflect. In this way, based on the multiple total internal reflections, the ray travel from one end to other end. This is the principle of optical fiber. In this diagram, at a particular for this incident angle, the ray which is enters the cladding region, and at this incident angle, it is greases the separation of the core and cladding, and for this ray, it is reflect in the same media. So these three cases we are showing in the same diagram, right? This is the concept of the principle of optical fiber. Thank you very much.